So today we will talk about this. As you can see, this is the Raspberry Pi Pico, which is the latest Raspberry Pi microcontroller. That's me unpack now. Okay, so as you can see here, I have ordered 2 modules of this Raspberry Pi latest microcontroller, I can say development boards, okay, which is based on RB2040 microcontroller. Okay, so these are again the latest Raspberry Pi microcontrollers. So these boards, they are microcontrollers, not a full what they call single board computer like the normal Raspberry Pi. Okay, so they are just a microcontroller, not a microprocessor. Microcontroller, just like an Arduino Uno, yet they are more powerful. Okay, then we will see later how and why they are powerful. Okay, for sure, because of the clock cycles very fast, this MCU support very fast crystal compared to the Arduino. This one, if I'm not mistaken, is a dual core 32-bit ARM Cortex M0. Okay, and also got 264 kilobytes of SRAM, and also support USB host and device. So it's kind of powerful MCU, for sure, definitely more powerful than normal Arduino Uno or any Arduino on the market, I can say. However, it's not as powerful as the normal Raspberry Pi or the standard Raspberry Pi. Okay, so if you see here, let me zoom in. Okay, take this apart. So these 2 modules, one of them come with a pre-soldered pin header. Another one is the SMD version. Okay, so let's you can see here, it's come with pre-soldered with all the main component. We have here micro USB B for power and data exchanging, also the MCU. Here is the main MCU that's been developed by Raspberry Pi team, which is a 2040, which has a dual core CPU with a 32-bit ARM Cortex. Okay, what else? Here we have LED. This is a programmable LED that we can control it. This button actually is not a user button, it's not like a programmable button, so we can use it to program or to trigger something, but no, to select the bootloader when we want to download the bootloader to the main MCU. And this MCU got no EEPROM or got no flash, so that's why they use the external one. Here's the external 2 megabyte quad SPI flash that we use to store our code. 2 megabyte, kind of high, kind of lot of data, a lot of program can be stored inside. Here we can see this is the Wi-Fi module. Okay, this is a Wi-Fi module connected to the MCU. This is the crystal. What else? I guess this is most of the component that we can see here, and for sure on both sides we can see the IOs. Okay, this boasts about different IO, different interfaces that we will talk about after this. Okay, when we go to the computer, I'll show you all the pin out and how we will use it when we go to the computer. Okay, so this is the physical how can I say, the physical appearance of the board when you buy the SMD version or the through hole, I mean the pre-soldered pin header. Okay, and by the way, if you see there's one difference between these two, which is this connector can be soldered. These are the debug connectors. Okay, 3 wires for debug connector. Okay, so yeah, that's all about the Raspberry Pi microcontroller. So now I believe we can jump to the PC to talk more about the pinout and also all the interfaces available and how to program it to do something.
So here is the pinout for the Raspberry Pi. We will start with the Raspberry Pi Pico. Okay, the normal one that comes without the Wi-Fi and the Bluetooth module. Okay, so you can see here we have a total of 40 pinout, 20 on each side. Okay, so this module or this microcontroller modules come with 26 GBIO in total, as you can see here. Okay, so we have a 1, 2, 3, 4 grounds on each side. We got the power supplies either from the USB or from the pinout. We can power up the module. It looks like support 3.3 volt out and 3.3 volt enable. And also it comes with a dual interfaces. Dual interface means come with 2 SPI, 2 I2C, 2 UAR, and about 3 ADC channels with 12-bit resolutions. Okay, and 16 PWM outputs. Okay. In addition to that, as I know, if I'm not making, got an internal temperature sensor. Okay, so if we compare this to the one with the Wi-Fi, okay, there it is. So you can see they are quite similar. I can say 100% similar, but we got some small this different between them, which is I can say mostly is the LED. Here's the LED is different, support different I/O compared to the previous one. Okay, so you can see I put them side by side. So these are the one without the Wi-Fi. It's currently the LED connected to pin 25. However, on the one with the Wi-Fi module, here's the Wi-Fi module. The LED now connected to another pin. Why? Because the 25, actually not connected, the Wi-Fi connected to the pin out of the Wi-Fi module. And the pin 25 module is being used internally in the Wi-Fi module. Okay? So you can see also the debug ports being shifted out from the edge of the Raspberry Pi to the middle. The rest I can say they are quite similar. Okay, so here are the pinout. We might need them later to design our circuit or to play around with this Raspberry Pi Pico. Open the Google search and we will search for Sony. Okay, so here we go. We will go to sony.org, okay, which is the Python for beginners, is an IDE. We go to this website. Here it is. It should looks like this, and we need to download the IDE. As the time or the date we record the video is 4.1.4. Okay, so for me, I'm using the Windows. I will download this one. If you use Mac or Linux, you need to download something else. Okay, so for the Windows, I will download the latest one, which is 3.10, and also recommended that I need to use this one. I'm not sure if in your time might be newer than this, but this is the latest one that recommended for my machine. Okay, so I will just need to download it, then I will run it. But for me, I already download and install it, so I just need to go to the start menu and search for Sony app. Here we go. Here is the app. here it is. So the app is already installed, and we're ready to move to the next step of connecting the Raspberry Pi microcontroller and try to upload a Blink code.
As you know, this microcontroller will come without firmware, okay, or without what we call bootloader. So we can program it using MicroPython or C. Okay, so now we will try to install the MicroPython bootloader or firmware. Okay, so that's why we have this button here, what they call boot select. Okay, they call it boot select button. So we'll use it to install the bootloader, the main bootloader, so we can use this device. Okay, so first of all, we need to press and hold the boot select while we inserting the what we call the USB cable. This USB cable is already connected to the computer, so I press and hold the boot select while I'm inserting the main this USB cable. So hopefully we can see the Raspberry Pi microcontroller will open as a flash drive or USB drive, so we can install the what we call the bootloader or the firmware for MicroPython. Okay, so I press and hold and insert. Okay, keep it hold. Here we go. As you can see here, it's been already open as drive on Windows.
So here you can see got some very useful information. Got the HTML web page and also a text. If we open this page, let's open another. Okay, this here. So this web page is from Raspberry Pi organization, is a documentation for the Raspberry Pi. You can see here got a lot of useful information you can get from here. Okay. For example, we can go to microcontroller, we can go to see all the family of the Raspberry Pi and what's the difference between Pico and the Pico wireless and all the pin outs, IOs, and all the documentation, even the data sheets you can find here. Okay. So now, as I told you just now, in order to install the bootloader or the firmware for the MicroPython, this is what we will use here. There are two ways to do so. First, we already connected the Raspberry Pi as in a bootloader mode, let's say. Okay. So now I will open Thorny again. Here it is, our friendly friend Thorny. So from here, we can go to here. You see here, actually, I already installed the MicroPython, but just for you guys to learn how to do it. So you click on the interpreter here. This is where it shows you which interpreter we're using. So then we click on install MicroPython. We can install the circuit Python or circuit Python, I believe, is for this what they call. Dang it, I forgot which company they use it. Adafruit, I believe. Adafruit, they developed this circuit Python for their own products, but for us, we will use the standard MicroPython. Okay, so when you click here, it will help you and guide you to automatically install on your board. But since I'm installed already, so it won't show you. That's why the installation button is already disabled. So from here, you can select which Raspberry Pi you're using, because it could be more than one, and also which family of the Raspberry Pi you're using. So yeah, then you just click install. Okay, so this is the first way to install the bootloader firmware. I'll cancel this. So the second one, we need to go to the page again. From here, we need to manually download the MicroPython file. Okay, so we go to from this where the main, this is the main Raspberry Pi documentation web page. Okay, we go to microcontrollers. I believe this will be auto selected once you open it from the drive. Go to MicroPython, get started with MicroPython. Then you go down here, this here will be explained to you what's MicroPython and all this thing. Okay, there's a wiki and the forms in case you've got any problem. And here it will show you how to do it. Okay, for us, we need to manually download the UF2 files. Okay, so first we need to know your variant since we are using the Pico wireless. So we should go to this one here. We're not going to the first one, so we click here. It will take us to where, it will download the latest file that's required for this. Okay, I'll cancel first. The latest UFL. Okay, so click here again. There we go. It's downloaded already, so we can download it here. Okay, so for me, I will be downloading it here since I already downloaded actually 2 times. Let's download it again. Do you want to replace? No, I will try to make this one as new. Okay, so it's been already downloaded. There we go. Okay, so now what we need to do is, first of all, we open the drive, the Raspberry Pi drive, and we go to where we store our, where we downloaded the UFL or the UFO, sorry, UF2. What do you have? UF2. Then we just need to drag it to the Raspberry Pi drive. Okay, so say I'll take this one. Okay, then I will drag it for sure. For example, this is the latest one we downloaded. I will just drag, then release it here. Okay, so it will copy the drive, the UF2 for us into the drive. Then I believe it will be automatically reboot the system and close the drive. Here we go. The drive is closed and reboot the Raspberry Pi. PC. Now we just need to disconnect the Raspberry Pi and connect it back again. So now, as we can see in Sony, we can click stop, restart. Yes, here we go. So it's already detected the Raspberry Pi Pico hardware, and we can start to do or run some testing. Oh, here we go. Okay, so now we can print any text we want. We made it. Okay, so now we are good with this. So now we can start to do our coding. So first code we will do is how to toggle an LED. Okay, this LED that is connected to the Raspberry Pi wireless actually is not coming from the microcontroller itself. I mean, Raspberry Pi microcontroller, rather than it's coming from the wireless module. So that's why we say it's a special LED. So in order to access that LED, we need to import from machine, import, we need pin and timer. Okay, so these two things, oh, sorry, timer we don't need it actually. We need only pin. We are not going to do blink anyway for this code. So to declare the object of the LED, we say LED equal to machine dot pin. Okay, so name is LED, comma machine dot pin dot out. We set this pin as an output. Okay, So now we just need to send the value to that pin or to that object, which is LED. We set the value here. For example, I want to set number 1 or true to activate the LED. There we go. So you can see here, when I set the value of the LED to 1, we can see the LED is glowing. Same time, if I just send 0 and execute again, there we go, is off. And by the way, I can execute by either press F5 from the keyboard or just click on this icon here. Okay, so again, 1, run from here, we can see, here we go. Or 0, and I can press F5. Okay, so now this is how we send value to the LED or to the special, this what we call special LED that's not connected directly. I mean, if you check the documentation and the schematics of the Raspberry Pi, actually this LED is not connected directly to the microcontroller, but is rather connected or comes from the wireless module, because the GPIO number 25 actually is being used and utilized as a one signal, I believe ZSDO to the Wi-Fi module. Okay, so here is how we activate it. This is how easy you can activate and deactivate, or what we call trigger on or off a pin on the Raspberry Pi microcontroller. So now we can go to develop the blink code, which is just need to, let's say, activate it first. Then we need to add some delay. Then we turn off. Then we need delay again. Okay, but we will do it in more proper way with a function and a timer to do all this whole thing. Because if we use a delay, you know, it's not good method to use a delay, because the processor will be keep looping, waiting, or do some operation instructions just for the sake of spend some time. Okay, so this one should be 0. So yeah, that's why we're going to use a proper function with a timer instead of delay, so we can do it efficiently. Okay. So what we will do is to blink the LED, but be careful, guys. The LED on the board is not on pin 25 as the normal Pico Raspberry Pi Pico microcontroller, because this one is the wireless one. The wireless one, this one will be kind of special, will be treated as special LED. First of all, let's develop the code together. So first we need to import from machine, we need to import pin, and we need timer. Now we need to declare the LED object. This is the LED, it's not directly from pin 25, but we have to declare it specially pin first. The pin will be called LED. This is our LED, which is connected to machine dot pin dot out. Okay, so this is how we declare our LED. Now we need to have LED state. This one we use it later to grow the LED. Okay, so this one we set it as true for time being. And also we need to declare the time, TME equal to timer, in the timer interrupt here. Now we define our task. Okay, so our task is, or our function is to blink our LED. So this task will be run according to our timer. Oh, okay. So here I will add the global LED. This is the object code that we declare up there. And also we need the LED state. So here we will trigger the LED state. So the LED state equal not to this one, not LED state. Okay. Then we need to set the LED value. By the way, before we go to this far, okay, so now we can use the LED value here, LED dot value, and we send our LED state. Okay, so this is our function done. Now we need to declare our timer. So timer dot initializing or init. The timer frequency, we want it to be 1 second, or let's say 1 hertz, which is 1 second for sure. Mode will be timer dot periodic. And we want the callback function, we edit here. The callback function is blink for sure. Blink. Okay. So now I believe we are ready to run the code. We just run it. System error at line 7. Oh yeah, sure. Sorry, need to add the semicolon here. Here we go. We can see now our LED is blink.
Blink code, okay, this is a completed one, and as you can see, the LED is blinking. So now I can play with the frequency. Let's say I'll increase the frequency to 3 Hertz. So I'll stop and run again. There we go, it's 3 Hertz now. If I change to 30 Hertz, there we go. I'm not sure if you can see, it's kind of blink faster. Maybe you cannot see, I'll change it to 15 or 18 Hertz. Yeah, you can see now, okay? So now we have finished with the blink, the built-in LED. And we will try to play with these 3 IOD. If you notice, I already add these 3 LEDs. Actually, I'm planning to add 4, which if we count this, but this one doesn't work. I believe it's burned or something. Okay. So let's see where I connect the LEDs. If you see here, I connect the LEDs here to here, here, and here, which are these 3. GBIO 14, this is GBIO 14, GBIO 15, GBIO 16. Okay, these 3, 14, 15, 16. Okay, so now we'll try to play with these 3 IOs. Okay, so come back to Tony and we will make new code, open new. So this is the new code. So first of all, we will begin using the machine to import pin. Okay, then we can declare our LEDs, the objects that we want to control. Could be LED, could be anything, but since we are using them as output, so we still maintain them like LED 1, LED 2, LED 3. Okay. So LED 1 will be equal to pin 14 and pin dot output. This is pin 1, same goes to the rest, so just copy. So this one 14, as we said, the first one, second one will be 15, and the last will be 16. Then we can just use the LED dot value. And for sure need to assign which LED you want to send. So LED 1, and the value you want to send is 1. So LED 1, which is pin 14, should be 1 now. So you try to run the code now. There we go. We execute the code. The first LED now is high. You can turn off it again. There we go. Now I will turn on the second LED. High. Again. You can turn off. There we go. And turn on the last LED, which is the third one. There we go. So yeah, this is the basics of getting the LEDs. So now we can put our code to make them like triggering or do some funny things. Okay, so what we can do, let's use a for loop here, but before we use the for loop, let's make this as a list. So here you can see in the LEDs list. So we have LED equal to empty list, and here we have LED dot append. We will append this guy here, so it's easy for us to access them later. Here also dot append, and here also dot append, and here no need the 2 or this because we just keep adding them to the same list, and here no need equal. And here we need to close the brackets. Okay, good. So now instead of LED 1 or 2, 3, we can just access them using the indexes. This LDC LED 0, which is LED 1. So now if we execute, should see something. Oh, 13, yeah, sorry, this one wrong. So we can run again. Here we go. So this one value 1, and let's turn on LED 1, which is 15, and the last one. Here we go. So yeah, we'll use the instructions now, so we can index them using for. So now I can use for I in range of which range? This range will be for sure from 0 to 3. Don't need this anymore. So this one from 0 to 3. So I will be indexing the list. Let's say I want to turn them off. So if I execute now, all of them will be off. Here we go. And if I send 1, so now should be all of them will be 1 because I indexed them using the range from 0 to 3. So yeah, with this, let's add some delays. You can see them because this one actually is not turned on at the same time or off at the same time. They are actually taking time to execute. I mean, each iteration will be controlling one specific LED, but we cannot see them here because it's too fast. So we need to import time, I believe. So we can add some delay, or don't have delay, but it's just sleep as the processor or microcontroller to sleep. So now I want the processor to sit still for 1 second. So now if I run code with 1, there we go. So should we see every 1 second go boom, boom, boom? Okay, that's good. So if I want to turn them off now, 0 execute, boom, boom, boom. Okay, that's good. So now I can, what to do with this? I don't know, I'm just like try to exploring with you guys. Let's say this one will be make them or turn them on, this one turn them off. So now we can see it will be go like on, off, 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 something like this. On, off, off. Okay, that's good. So now if you want them continuously running forever, we just need again add the while loop. While true, which is always true, we just keep this one here and put them under the while. So now should be it. There we go. On, off, again, on. There we go, and it will be continuously running forever. Okay, so yeah, this is how we can play with them. I mean, this is again just an output. Maybe later in the future I'll try to do something with the input and other interfaces. However, this is basics and how easy we can make our code with these microcontrollers. Kind of powerful microcontroller. I have a lot of things, a lot of idea in my mind to do with this microcontroller. Okay, but so far these are the basics. Okay, so before we go to the next step, which is I'm planning to go to play with the ADC and the PWM, I want to mention something actually here. If you notice now it's running, okay, and here also shows that this is running, but you have to notice something. Now I will try to disconnect the Raspberry Pi. Okay, now it's disconnected and connected back again. You see it's not running anymore. Okay, and at the same time the code is not there inside the Pi anymore. If we open, I don't want this computer, I want to open from Raspberry Pi, you see the Raspberry Pi is empty. So it means all the while these two codes, they were running on the Pi but from the computer. So I mean the computer, the phony was sending the instruction or send the code to the Raspberry Pi but not save it inside. So now if I want to save it, I can go, let's say, on here, then I can save it. For sure I don't want to save it in this computer, I want to save it in Raspberry Pi. The device is busy. I need to turn off, I believe. Okay, no problem. I stop the execution now. Now I believe, here we go, I can save it. So I can say this one, I can name it as 3LEDs.py. Save. There we go, saved already. And this one also I can call it LED or built-in LED. Built-in LED blink.py. Okay, here we go, it's saved. And if we run it, let's say now I want to go to blink, here we go. But there is another thing. The code now inside the Raspberry Pi, but if we restart, let's say I restart the Raspberry Pi, again, it's not auto run the code that we run that we save inside. Okay, if we reset the module, now I go to open Raspberry Pi, you can see, yes, I have these two, but they don't auto run. How to make them auto run? For sure, this microcontroller should be automatically run the code whenever it's been booted up. Okay, so no need to like connect it to the PC and say, oh, run this one or run that one. Let's say I want this code to be run automatically whenever I connect the power to the Raspberry Pi microcontroller. The secret here, or the method, is by saving this one. Let's see if we can change. I don't think so. Rename, can I rename OpenThony at the file properties? Okay, so the thing here is we need to save the code as main. Let's say I copy this, I make a new folder, a new file, sorry, and I don't want it to be sleep for 1 second. Let's see, this was sleep 1 second, isn't it? Yeah, this one, let's say 1 second. I want it to be run, let's say, can I reduce this to 0.5? Let's see, 0.5 will be faster. Yeah, here we go, it's faster now. So now I wanna save this, and I mean this one I want it to be run automatically whenever I connect the Raspberry Pi to the power, so I can save it into the Raspberry Pi, but I need to save it as a main.py. Okay, main.py is the piece of code that the Raspberry Pi will be read it first or execute it first whenever it's start to boot up. Okay, so if I save it as a main, okay, so the main is already there in the Raspberry Pi, so now I will just disconnect the Raspberry Pi and I connect again, and I should expect the one will be running. Here we go, see, I just disconnected, connected again, and it's running again. Disconnect, connect back again. Once the power connected to the Raspberry Pi is directly detect the main code and start to run. Okay, so yeah, I believe that's it for this step. Now I'm not sure if I will make this as the one video or more than one. If it's kind of bit too long, might be boring for you guys, so I'll try to make it maybe two videos. It depends on the progress. So yeah, the next will be playing with the ADC and the PWM signals.
Well, now we will talk about the PWM signals. So we will use the PWM to dim the LED that we have here. This one I already connected to pin 21 of the Raspberry Pi Pico wireless, which is GPIO number 16. Actually, from the pin out diagram here, you can see all the GPIOs on the Raspberry Pi are supporting the PWM, as you can see here. Okay. So now I will open Thony and start do the coding for the LED dim. Okay, so first we need to import from machine again. Import, we need the pin and we need the PWM, pulse width modulation. Here should be import, not import. And also we might need time, so I will import time as well. So first thing we need to do is to set up the PWM pin, or define or declare the PWM pin. So LED PWM equal to PWM on pin number 16. Yep. Then we set the frequency. Set the frequency by calling the LED PWM dot frequency, sorry. Set the frequency, say 1000 Hertz. Now we can set the duty cycle. Set duty cycle by using LED PWM dot duty underscore U16. Then here we declare the duty cycle.
So the duty cycle starts from 0. Okay, we start from 0. Now we run the code. Okay, you can see here is running, and the LED is off for sure because the duty cycle is 0. We start to increase the duty cycle. Let's say make it 100. Run again. If you can see, kindly like almost almost turn off. Here we go. You see, there's a bit of glowing there. Make it 1000. Should be more. Here we go. So the maximum duty cycle we can set is, I believe, 60 something thousand, 65, 536. This is the full brightness. Here we go. Okay, so start from 0 to 6536. Yep, full brightness. Okay, so now we can develop our code based on the duty cycle changing. So we can make it like auto dimming. Okay, so now we need a while loop, while true. It's always true. So here we increase the duty, and here we will decrease it. Okay, so to increase it we need for sure for loop, for duty cycle in range of, we start from 0 until, as we say, is 65,536 with step of, let's say, I don't know, say 200, 250. This is the step. Okay. Now what I want to do, I want to change my duty cycle or display my duty cycle here. So we'll not directly set the number, but we will follow the duty cycle. Then we give time to pause the process so we can see it in millisecond. Let's say 2 milliseconds should be okay. So now the decreasing, or the step down, we go down now. Again, we use for duty cycle in range. This time is from 6536 into 0, and the step will be minus 250. Then we need to copy this exactly. There we go. I believe that's all. We declare, we call the packages we need and declare the pin that we use it for the dim LED frequency, and also we play with the duty cycle. Let's test it out. Should be okay. Nope, there is line 16 got issue. For duty cycle in range. Why got issue here? Inval sent. Oh, sorry. We need the semicolon here. Then we run again. Here we go. We can see here the LED is fading in, fading out now. Okay. So again, we declare the PWM pin on where we connect our LED, and I can say from the pin out all the IOs that are supporting the PWM. Set the frequency here, then we play with the duty cycle. Okay, good. Let's move to the next step. So now we have reached to the last part of this tutorial, where we will talk about the ADC input. Okay, so you can see here, let me open the pin out of the Raspberry Pi.
So now I connect potentiometer. As you can see here, I'm using this potentiometer, the 10 turns potentiometer. I connect it to GPIO 28, which is also ADC2. Okay, and for sure the wiper, I connected to GPIO 28, and the first and the third leg connected once. The first one to the ground, the second one, the third one go to the 3.3 volts. Okay, so you can see here, this is ground, 3.3 volts, and the middle one goes to the 28, which is ADC2. So now I will open Thony, I'll start to do the coding. So at the beginning, we need to import the ADC and PWM from the machine. From the machine, import. We need the pin, ADC, and also let's import PWM because this one will use it to dim the connected LED. And also let's import the time. From time import sleep. Okay. So now we need to declare our ADC object equal to machine.adc. So now where I connect the ADC, actually connected as we said just now to pin 28. Now let's display the ADC readings on the shell and see if our hardware is correct or not. So while true, I want to ADC value equal to ADC dot read underscore U16. Okay, so this function will return the ADC readings. Then I will print it out. Print the ADC value. Then I will set the processor to sleep for a while to display the readings. Sleep for 0.01 seconds should be enough. Okay, so let's run this code and see. There we go. So the readings now is 7,000 something. Now I'll try to change the what they call a potentiometer. So here we go. You see when I turn clockwise, it's go up 11, 12, 15, 16, 17, 18, all the way up. Okay. So now I will bring it down again clockwise, and you can see the readings going down. Okay, so our ADC is working correctly and the hardware is also correct. So now I will add the PWM part. So first I will declare the PWM LED. Again, as we learned previously, the PWM LED equal to PWM at the pin of this one connected pin 16, and now we need to declare the frequency LED PWM dot frequency (1000). Okay, so here we declare the LED or the PWM LED objects, and here we set the frequency. So now after we read the ADC value, now we need to send it as a duty cycle to the LED PWM dot duty underscore U16 of the ADC value. Okay, so here we read it, we send to the duty cycle of the LED, at the same time we print it out. Okay, that should be fine. Let's run. Here we go. So you can see now the reading is 3000 and the LED is kind of dim. kind of tricky. So okay, so now here we go. You can see the readings going up. Let me move the mouse side. Okay, so while the readings up, the LED getting brighter. Okay, now I go down clockwise. Now the LED will be dimmer and dimmer. Here we go. If you can see this, you can go down to 300. Okay, this potential I connect is about 10K, so kinda, I mean, the LED won't go all the way full bright or full off because of non-linearity of the potentiometer. Okay, so you can see here our code and the hardware function as intended. Okay, so I'm happy with the result. That's good. Yes, guys, so we have made it already. Few examples and hands-on with the Raspberry Pi Pico. And for sure, this is just the introduction to the Raspberry Pi. There are much more we can do, but this is the more basic things we can do with the Raspberry Pi. So I hope you have learned something new today, and please let me know if you need any more examples or any specific things you want me to do. Thanks a lot for watching. See you soon.